I think so. I'm live. Okay. Hmm. Mm, Farthest building you can reach. You're given an integer array heights representing the heights of buildings, some bricks and some ladders. You start your journey from building 0 and move to the next building by possibly using bricks or ladders. While moving from building I to building I plus 1, 0 index, if the current building site is greater than or equal to the next building site, you do not need a ladder's bricks. So, for example, let's say the building is of height 100, next building is of height 100, greater than or equal to, then I don't need to jump because I can just walk, right? Or if it's greater than or equal to, so if it's let's say 99, then I can probably walk, right? Because it's height comma. If the current building height is less than the next building height, you can either use one ladder or bricks. Okay, let's say the current building height is 100 and next building height is 105. Then if the current building height is less than the next building height. Current building site, let's say I'm currently here. Current building site is less than the next building site. Yes, it is. Then you can either use one ladder or what is h here? H of I plus 1, h. H is heights. Acha, okay. So you can use h of I plus 1 minus h of I blocks. So for example, in this case, I can blocks or bricks, right? So I can use 5 bricks to go from 100 to 105. I've not submitted this earlier now. Yeah. And one other way is I can just use only one ladder. So I think so one ladder is fine, right? Minimum number of moves पूछा है क्या? Return the farthest building index you can reach if you use the given ladders and bricks optimally. Okay, so the farthest building I can reach. So like there could be many buildings like this, and I have to determine like which is the farthest building I can reach sequentially, right? I have to reach linearly. ये क्या बना के रखा है? Okay, this person used a ladder. Okay, wait. So he just dropped here, used bricks, jumped, used a ladder, and then so on. Okay. 4 to 7, 6, 9, 4 to 7, 6, 9, 14, 12. Bricks is 5, ladders is 1. Output is 4y. Starting at building 0, you can follow these steps. Go to building 1 without using ladders, not bricks since. Acha, 0 index, right? So 0, go to building 1 because I don't need from 4 to 2, I can just jump. From 2 to 7, I need 1 ladder or 5 bricks. 7 minus 2 is 5. So it's saying go to building 2 using 5 bricks. So they have used bricks. Okay, great. Go to building 3 without using ladders, nor bricks since 7 is greater than or equal to 6. Yes, it is. Then 6 to 9 में क्या कर रहा है कि like they are simply using one ladder, right? They're using only one ladder. Now I'm at 9. From 9 to 14 I can use one ladder, but ladder has been used. Bricks remaining is 5, right? Or 5 minus 5 because 5 bricks has been used here. 2 to 7 में jump में 5 use हो गया. So I cannot use 5 here, right? So I think so it will be 1, 2, 3, 4, 5. 5 should be the answer. Why is 4 the answer? What do I have to return? Return the furthest building index. 0 index. Okay, so yeah, this 4 means 5 because like 0, 1, 2, 3, 4. Fourth index. Okay. अच्छा इसमें क्या है? Bricks is 10, ladders is 2, some answer 7, and then 0 and 3. Okay, let's see this one. So 4 to 12, maybe I can use one ladder. 12 to 2, no ladder required. 2 to 7, let's say I'll use bricks. So 5 bricks remaining, no bricks or ladder required. 3 to 18, one ladder used. 18 to 20, bricks used. And I think so from, yeah, I can go till here. 19 क्या 16 हो जाएगा, right? And I cannot use it. So I think so 0, 1, 2, 3, 4, 5, 6, 7 is the answer, and 7. Okay. Ladders is 0, bricks is 17. 14 is a 3, no, nothing required. 3 to 19, 16 bricks is required or one ladder, but ladders is not there. So 16 bricks. Okay, one brick remaining, right? Only one brick remaining. Only one brick remaining. Now 19 से 3, no jump required. So like 0, 1, 2, 3. 3 answer. Okay. So to return the farthest index wala building I can reach, right? Okay. So when I'm at the Ayat building, so I'll say when I am at the Ayat building, I have the option. So when I'm at the Ayat building and it requires the usage of resources, then I have first option is that I can use ladder if it's what do I say, available, or if it's left. And other thing is use bricks if remaining, right? Uh, if remaining, right? Bricks if remaining. And then I have to find out, okay, so I have two options, right? So maybe I can go for greedy approach. Will greedy approach work? Okay, so my result, or which is my answer. Okay, let's firstly define the length of the heights here. It's not given, length of heights, and my result is going to be solve of, like, my length is provided, heights is provided, bricks is provided, ladders is provided. So could be dynamic programming, because not dynamic programming, like, it can be optimized to DP, but recursion should be applied here, because at every building I have two options. If ladder is remaining, use that ladder, or if bricks is remaining, use that bricks. And I have to optimize it, because I feel like there can be a test case where if I go for uh, there can be a test case where if I go for greedy approach, wherein I use all the bricks first and then ladder, or if I use all the ladders first and then bricks, it's not going to work. So at the end I have to return result, right? If it's not something I can do, I'll look at the discussion. Should I look at hints? Heights का length क्या है? 10 to the power 5. अच्छा, okay. This is never a concern for me. Heights of I. Heights of I is this number, right? And heights length is 10 to the power of 5, which is this thing. Bricks is 10 to the power 9. Yeah, this is a concern for me, because I cannot just take this, right? Ladders is heights dot length. Okay, it could be a greedy approach, na brute force. Them simple. So in this case, let me see. In this case, what I can do is, let's say in the first test case, we have the numbers 4, 2, 7, 6, 9, I guess 14, and then 12. So I'll go forward and I'll try to see how many ladders or bricks is required at this moment. So, like, if I go from, currently 0 is required, none of it is required. Here also none of it is required. Here I can use, maybe this is my information, this is my ladders, and this is my bricks information. So currently 0 bricks is required. If I go from 2 to 7, then at this point I require how much? I require one ladder, or if here I require 5 bricks. Okay, at this point I require 0 ladders, and here I require 0 bricks. Here I require 1 ladder, here I require 3 bricks, right? Okay, here I require 0, like 1 ladder, and here I require 5 bricks, and over here I guess I require 0 of it and 0 of it. Now what can I do with this information? Prefix ले सकते हैं, right? So prefix sum would be what? 1. So I know कि at this index how much ladder is required. No, it's not 0, it's like sum of all of this. So 1 plus 1, I'll just do a prefix sum. 1, this will become 2, this will become 3, and this will become 3. So it says that to go to the very last building, it requires at max 3 ladders, right? Where 1 here, 1 here, and 1 here. That's it. For bricks, it says something like this, that over here it will be still 5. Over here it will be 8 plus 5 is 13, and then 13. So again this says that to go to the very last building it requires 13 bricks. Why? Because this is 5 bricks, 5 plus 3 is 8, 8 plus 5 is 13, and there's none required here, 13. So with the given information, like bricks is 5 and ladders is 1, 5 1 5 1, at where's the farthest I can grow, like where's the farthest I can go to? I see 5 and 1 is being up here, right? Like 5 and 1 is here, 1 is here and 5 is here. What should I use first, bricks or ladders? Here as well, if I just use the bricks optimally, then yeah, I guess I cannot use bricks here, right? Yes, because it's like 8 remaining, right? I need how much? 8 bricks. So if I use it, great. तो बाकी है, I cannot use it, I use a ladder. I cannot use it, I use a ladder. So I can use it. And I'm left with nothing. 14 3. Acha, let's go for the brute force now. Let's not go for this, let's go for brute force first. So brute force क्या है कि I'll start from this index. So for I in range, for I in range, 1 till n is the length of heights. 1 till n. I'll see here that if heights of I is less than equivalent to heights of I minus 1, in that case I know कि none is required, so I can just simply continue. Or I don't even need to check for this, right? So if heights of I is less than equivalent to heights of I minus 1, or if heights of I is greater than heights of I minus 1, greater than the previous height, then how much bricks is required? I'll say required bricks is like the difference of this. So heights of I minus heights of I minus 1, and maybe required ladder is 1 itself, so I can simply say required ladder is 1 itself. Firstly I'll prioritize bricks here, right? So I'll say कि if required bricks is less than equivalent to the number of bricks which is remaining, in that case number of bricks minus equivalent to required bricks makes sense. So for example, bricks remaining is 100 and required bricks is 99, which is less than equal to 100, then remaining bricks becomes 1. Makes sense. LF ladders is greater than 0, which means it's still there, then ladders minus equivalent to 1. Else I'm saying that my answer, like the farthest I can reach is, okay, so the farthest, like initially it's 0 because I cannot reach, like initially I'm starting from 0, so farthest is 0 itself. Else I'm saying that my farthest is equivalent to I minus 1. The reason being, yeah, I cannot reach ith one, right? And then I'll also break from here onwards. At the end I'll return farthest. I mean, see, this is going to work for test cases like this. Like, this is going to work for this if I am not wrong. And it's also going to work for some test cases like this. So we have 4 12. I can just copy it now. Okay, wait. I'll just paste it, and bricks is 10, Ladders is 2, and if I run it again, it's going to work. It's also going to work for this. I think so. This should not work in the long run because there can be some place wherein, yeah, it's the wrong answer. So expected was 3. Hmm. Okay, did I missed out on something to provide here? What's my answer? My output is 0, right? Okay, so every time my farthest gets updated, right? So farthest is I. Hmm. Every time it gets updated, if I'm not wrong. Hmm. So if I submit this, this should not work because brute force should not work. Yes, as expected. Let's see the entire test case here. So it's saying 4 and 1, right? So if I used 4 bricks here, none is required here, and I used a 1 ladder here, then I can go to 0, 1, 2, 3, 4. Like 0, 1, 2, 3. I can go at max till 2, right? Yes. But mhm. But what if I used 1 ladder here instead of 4 bricks? So right now nothing is required here. I use, let's say, 1 brick here, 1 brick here, 1 brick here. So I can reach till 4, right? So it would be 0, 1, 2, 3, 4, 5. Yes, 5 should be the answer. I expected this to happen because this is not going to work for every, what do I say, every test case. So again, I have the option to do something here. Let's see. Mhm. So let's define this function solve. And I guess currently I'll be at which index? I'll start from the index 1. So this 1 is nothing but the index. So I have the index here. I have n, and I have the heights. I have bricks. I have number of ladders. That's it. Okay. What could be the base case here? I will determine it. Will determine it. No problem. If let's say my index comes at n, then I'm like return 0. I don't know why am I doing this, but feels like this could be the base case, because if I go out of bound, I should return simply 0, or I could return an infinity value. We'll see to this. Infinity, or maybe in negative infinity. We'll see to this. Okay, when I'm at the current index or the current building, then I'll see if mhm, if the heights of I idx is greater than heights of idx minus 1. See, idx minus 1 is never going to be a problematic thing because I'm starting from 1 itself and I'll move forward. So it's never going to be a problem. If heights of idx is greater than heights of idx minus 1, which means the current building is greater than the previous building, then the required bricks is something. So in this case, the required bricks, I'll just write required B, is going to be the difference of this. So if I just get the difference, it will be great. And the required ladder would be 1 itself. It's something I don't need to write. So I have two options here. The first way is that I choose the bricks option, right? But when will I choose it? I'll choose it when it's feasible, right? When it's feasible. It means key the required bricks is available to me. So if required bricks is less than equivalent to bricks, in that case my way one is solve of idx plus 1. I need to go to the next index heights, and this should be like simply bricks minus required bricks, right? And then ladders will be as it is. And again, the way to could be, if let's say my ladders is still remaining, right? Ladders is greater than 0, or I can simply say if ladders, then in that case way 2 could be a solve function at like let's say idx plus 1, and heights bricks will be as it is, by the way, and ladders minus 1 for sure. And using these two approaches, if I choose the way 1 or way 2, I have to see what is the farthest index I can go to, right? What's the farthest index I can go to? Okay. This is a little confusing. By the way, my both way 1 would be 0 and like way 2 would be 0 initially, because I don't know till when I can go to, or it could be as simple as idx minus 1, idx minus 1, right? At the end, like idea would be to simply return the maximum of way 1 and way 2. That's it. If that's not the case, right, like in this case I know ki this is not the case, in that case what can I do? I mean, I can just simply go to the next index, right? Then in that case I know like my both way 1 and way 2 is simply idx minus 1, or it's idx itself, and way 2 is idx itself. So there's only one way, right? Like there's only one way. Where is idx? Better, I'll return idx. No, it's not the way. Solve idx plus 1 n heights bricks will be as it is, ladders will be as it is, right? And then at the end I can like probably return way. In this case I have to simply return the max of way 1 and way 2. See, at this point I know key way 1 and way 2 is idx minus 1. I can reach the previous building for sure. I don't know if I can reach the current building or not, right? So that will be determined by this variable. And once, okay, great, kind of makes sense. I'm not sure, not sure at all. This is wrong. Output is 1. Let's see why. 14, 3, 19 and 3 is there, 17 is there, right? Okay, idx is n, return 0. I think so. I just need to return a value like idx itself or idx minus 1 in this case. It's running. What about this test case? If it fails, I have to probably go and look at the discussion section. This is 5. This is 1. Let's run this. It's passing. Okay. And we have 10 bricks and 2 ladders, right? So we have 10 bricks and 2 ladders. I'll run this wave 1, wave 2. This is working, but this should give me TLE, right? TLE means I have to optimize. Straightforward. TLE, हाँ ठीक है. What could be the optimization? Like hash map is something I can take. I'll pass it here. Hash map, and then here as well I'll take in the hash map. I'll take in the hash map, and here as well I'll take in the hash map. What can I optimize? I can optimize the current index and the number of ladders and the bricks left, right? That's something I can do. But that will make it more complicated, right? Let me see. Where there could be overlapping problems. There is bound to be overlapping problems for sure, because it's bound to be overlapping problems. If idx comma ladders in hash map, then I'll return hash map of idx comma ladders. But again, there could be bricks as well, right? So I'll have bricks as well here. idx comma this thing, and then I'll have bricks here as well. I see the space complexity part being shooting up, right? And in this case, instead of returning, like before returning this, I'll say hash map of idx ladders, and then bricks is equivalent to max of this thing. Before again returning this, hash map of idx ladders and bricks is the way, and then like here as well I have to return this and that. So why don't I simply return at the end, return hash map of whatever this is, idx ladders and bricks. Should not run, I mean should give me memory limit exceeded. It's running here, but it should give me memory limit exceeded if I'm not wrong, because 10 to the power 9 is very much, like it's too much of a thing. I have to think of another way. Memory limit exceeded as expected. Okay, what could be done here? Should I just use ladders or no? If I simply optimize it with ladders, then it's never going to make sense, because both bricks and ladders is required. Ladders. I have to look forward to a solution here. Submit. Should not run. Should give me a wrong test case, like wrong answer. Wrong answer as expected. So either of them should be optimized here. The problem here is the bricks part, 10 to the power 9, na? Hmm. 10 to the power 9 is the problematic thing. Okay, let's look at a different way to solve this. Let's say in this test case 1 5 1 2 3 4. Firstly I require, okay, so bricks required is in order, required is 4, then I guess 1 1 1 4 1 1 1, then I guess it's going to be 9996, and ladders required in one of all of these cases is 1 1 1 1 and 1. Can I use minimum heap to solve this? I don't know. Available to me is 4 and 1. So like bricks available is 4 and ladders available is 1. 1 na ki 2? 4 and 1. Okay. What can I use here? Again, like I have the option to simply go for, yeah, I guess I can just simply go for this 1 here. At the very first place. Okay. Okay, let's see some hints here. Not able to related topics. Heap. Okay, heap will be used. Show hint 1. Assume the problem is to check whether you can reach the last building or not. Assume the problem is to check whether you can reach the last building or not. You will have to do a set of jumps and choose for each one whether to do it using a ladder or bricks. It's always optimal to use ladders in the largest jumps. Okay. Okay. In the largest jumps, I can use the ladder, else I won't. Okay. Iterate on the buildings, maintaining the largest R jumps and sum of the remaining ones so far, and stop whenever this sum exceeds B. Whatever B is, right? Iterate on the buildings, maintaining the largest R jumps. Iterate on the buildings, maintaining the largest R jumps and the sum of the remaining ones so far, and stop whenever this sum exceeds B. Largest R jumps and the sum of the remaining ones so far, and stop whenever this sum exceeds B. So I guess for this one, I have to um, use ladder because this is the one of the largest ones, one of the largest bricks area. It makes sense that wherever the bricks required is most, I'll use the ladder, right? Like in this case, 5 bricks is required, 3 is required, 5 is required. So probably I'll go for the fifth one, right? So firstly, I'll go for this 5. It's also saying ki, where is that R thing? Iterate on the buildings, maintaining the largest R jumps and the sum of the remaining ones so far. R is nothing but the number of ladders, right? R big jumps. Acha, take this test case. Assume problem बोला था, assume if you can reach the very last building or not. So in this case, I know I'll require 9,996 jumps. So probably I'll go for a ladder implementation here, right? I'll go for a ladder. Huh. Then here onwards, okay. Hmm. let's say I use a max heap. Okay, let's say I use a max heap. Okay, let's say I use a max heap. Max heap में क्या रहेगा? Max heap में starting में 4 आ जाएगा. Then 1 will come in because from 1 to 2 I require 1. Then 2 to 3 I require 1. 3 to 4 I require 1. 4 to 10,000 I require 996, right? Okay. This is something the max heap will look like. Complete binary tree रहेगा. Put 3 expected 5. Output is 3 expected 5. So in this case, what could be the approach? I cannot think right now. Discussion जाना ही पड़ेगा. Priority queue. Let's see this one. Greedy solution may be wrong. Yes, Leetcode messed up the test cases again. Okay. Explanation: heap store k height difference that we need to use. Ladders each move the height difference is we push d into the priority queue. PQ the size of the queue exceed ladders. So you have to use bricks for one move. Then we pop out the smallest difference and use bricks. If bricks is less than 0, we can't make this move. Then we return index I. If we can reach the last building, we return a dot length minus 1. Okay, complexity is n log k. Like, what is the code here? I just need to look at it. Okay. What the fuck, my brain hurts. Okay, I'm not solution. The idea is very similar to minimum number of refilling stops. Maximum was the default ID using bricks as long as when the jump is too big, replace the maximum jump with the ladder. So basically use bricks and replace with ladder. Okay, so in this case heap is empty. Great. For I in like range पीछे से जा रहा है. Okay, D is going to be okay, so D is going to be of I plus 1 minus A of I if D is greater than 0, which means like the next building is greater than this. So heap q dot heap push heap comma D. That difference has been pushed in. If length of heap is greater than ladders, in that case it is not. Okay, in that case it's saying bricks minus equivalent to heap q dot heap pop heap. So it's just using the min heap implementation, right? Not max heap, if I'm not wrong. जो सबसे मिनिमम वाला है वो ब्रिक्स से सब्सट्रैक्ट कर दिया. एंड इफ ब्रिक्स इज लेस देन 0, आई एम रिटर्निंग आई. मेक सेंस. Or at the end, if I'm not encountering this condition, I know I've reached the very end. So therefore I'll return length of a minus 1, which is the last indexed building. Okay, so what is he doing? Firstly, okay, let's say this is my min heap. Okay, let's say this is my min heap. Instead of max heap, this is my min heap. And for this test case, 1 5, right? So 4 gets inserted, and I know this length is not greater than the number of ladders, which is 1 here. So what I'll do is, as a part of the next step, I'll again compute D, and after computing D, I see I'll require 1. So once I insert 1, min heap looks something like this. Now this length is greater than ladders, so what I'll do is I'll pop off this 1, right? I'll pop off this 1, and from bricks ka count, which is 4, I'll subtract this 1, so bricks currently becomes 3. Makes sense. Again, I require from 2 to 3, it's 1, so again min heap looks something like this. But again, length of min heap is greater than the number of ladders, so again I pop 1, and therefore I'll subtract 1 from here as well. Okay, this process will continue until I get to something like 1 comma 4. I remove 1, and 2 minus 1 is 1. From 4 to this thing, this will look something like 4 9 9 9 6. Now again I'll remove the smallest element 4, If I do this, I'll get -3, which is again less than 0. So this is, what do I say, end of the day. So in this case, I just have to return the index itself. That's it. Okay. So let's try run for this test case 14, 3, 19, and 3 wala, right? Or this one. This looks great. So initially, what is the number of bricks? It's 10, and ladder's count is 2. So what's my mini going to store? 4 to 12. 8 is something which will be there. 12 to 2, 2 to 7. 5 is something which will be there. 5 and 8. Okay. Now right now, mini length is not greater than the ladder's count. 2 to 7, 7 to 3, 3 to 18, right? So currently I require 15. So probably this looks something like this. Now since this is of greater length and this is like of length greater than the number of ladders available, I'll take out the very smallest element from the min heap and I'll subtract from the ladders. That's what the algorithm says. Then 18 to 22, so 2 when comes up, it's again the smallest element. Again, this length is greater than the ladder's length, so I'll say something like this, that okay, remove the smallest element from here onwards and subtract it from here itself, so this becomes 3. Makes sense. 20 to 3 I require nothing. 3 to 19 it's 16, right? So like probably 16 comes up here, and again since this length is greater than the number of ladders available, so I'll probably remove 8, and when I do something like 3 minus 8, I see the value is -5, which is less than 0, and therefore I'll end the process and I'll return the index itself. Makes sense. Again, this approach is valid, but since the number of, what do we say, see, for this test case it should run, right? If I'm not wrong, its memory limit exceeded, that's the problem. Let's remove this, paste it, but this should run because wrong answer. Okay, for which one? Wait, go a little down. Ladders and bricks. So like for example, if I do bricks and if I do bricks, where is it? Bricks, and then let's say bricks, and then let's say bricks. So this is going to work, right? It was working for recursive and DP solution. Yeah, it's working. But the problem here is what I'm creating is a time complexity of IDX into ladders into bricks. The number of, let's say the number of the height of the heights is n, number of bricks is m, and number of ladders is k. Then the time complexity is big O of n into m into k, and followed by the space complexity being the same. Space is also same. And that's the problem, right? And since number of bricks is like 10 to the power 9, so 10 to the power 9 will never pass in 1 second, never. Okay, this is why it's not working. Okay, let's get rid of this, and let's say for I in range, I'll import heap queue. So import heap queue. For I in range, I'll go from, I have two options. I can go from 1th index, or I can go from, okay, let's go from 1th index. It's not a problem. If I go from 1th index, I guess my farthest, initially like my farthest I can go to is 0. From 1 I'll go till n, and here itself I'll see that, let's say if the height of the current building I is greater than the previous building's height, which is I minus 1, in that case I know that there's some difference, so I'll insert that difference here, right? Yeah, so again I'll introduce min heap here, which is empty right now. So I'll say heap queue dot heap push into my min heap. Please push in the value, which in this case is heights of I minus heights of I minus 1. Great. And then here itself I'll say key if the length of my min heap is greater than the ladders which is available to me, in that case I'll remove the, like, what is my smallest value? It's going to be heap queue dot heap pop from min heap, and in my bricks I'll subtract the smallest value. Once done, I'll say here that if my bricks count is less than 0, I know I've reached the end of the process. In that case, I can probably break out of all of this. Else I can say the farthest I can go to is I minus 1, or I can go to is I, and I think so I can return farthest, right? Let's see if I run this. Accepted, and I think so it should be good for all of it. Okay, good problem by the way. And again, this is going to work, but for larger test cases, it's never going to work. It's a good foolproof solution, but okay, it's a good thing. Minimum heap. Like the idea says ki, idea says ki jitna bigger bricks required है, right? Just shift it to the ladder section. Okay. Let's do something else. Short encoding of words. पता नहीं क्या question है ये. Not done this, right? No, not done this. Okay. A valid encoding of an array of words. Okay. A valid encoding of an array of words is any reference string s and an array of indices such that words.length is equivalent to indices.length. The reference string s ends with the hashtag character. For each index, indices of I, the substring of s starts from indices of I and up to but not including the next hashtag character is equal to words of I. Given an array of words, return the length of the shortest reference string as possible of any valid encoding of words. The question is very the valid encoding of words. Let's say words is given and time, me, and bell. Output is 10. Why? A valid encoding would be, what do I have to return? Return the length of the shortest reference string as possible of any time, me, and bell. A valid encoding would be s is equivalent to time hashtag bell hashtag, and index is 0 to 5. 0 because like this starting from here, me because 0 1 2 2 say me is starting, and then bell is here because like 0 1 2 3 4 5th, right? A reference string ends with the hashtag character. So in this case, like 0 से start हुआ, so it ends up here. 2 से start हुआ, so me ends up here because hashtag character से end होगा. For 5, 0 1 2 3 4 5, bell ends up here because hashtag is there. Okay. Words of 0 is time, substring of s time. Okay. Words of is me, again it's ending up here. Makes sense. So for t it should be t hashtag. Makes sense. 2. Okay. Words dot length is 2000 and words of I dot length is 7. So like the word is never going to be of length more than 7, and the total number of words in this words array is going to be restricted to 2000. Words of I consist of only lowercase letters. Great. Why do I feel like this is a try data structure? Like match karna padega, something like this. Please don't tell me it's try because I have not. Yeah, it's try. I have not revised try. Okay, I'll do it later on. I knew it. It was try. Like hash map use hoga and okay. I even forgot the try representation. Like it was something like this, right? Ki T is there, and then let's say I can go to I can go to M, I can go to E, and like for each one of them there is a flag value F which is 0. Here also flag is 0, flag is 0, flag is 0, and like after E I guess we used to put flag is 1, which indicates that this is the end, right? And when it's me, right? When it's me, in that case, I see, is M here? No, it's not there. So I sequentially search for M and I find that, okay, M is there, E is there, ME is there. So probably I'll have ME, and this could be also 1. Okay, I'll skip this one. I'll see this later on. KIF try. I have to revise try. Search searching systems, binary tree, cameras, longest palindromic substring, longest string chain, delete operation for 2 strings. This looks good. Delete operation for 2 strings. Have I done this? No. Okay. Given 2 strings, word 1 and word 2, return the minimum number of steps required to make word 1 and word 2 the same. Acha. In one step, you can delete exactly 1 character in either string. In one step, you can delete exactly 1 character in the either string. See and eat. Okay, so in this case, output is 2 because you need one step to make C to E, A, another step to make E to EA. Okay, so for example, in this case, I delete T, in this case, I delete S. So total would be 2 steps required. One character in either string. So I can delete in any one of these strings. That's the flexibility I have. Word 1 is Leetcode, word 1 is Leetcode, and word 2 is ETCO. So probably ETCO is this thing. So I guess I need to remove 4 of these. 1, 2, 3, 4. Yes, 4 is the answer. Okay, so what are the possible options when I'm given 2 strings? S1, some value is there. Let's say some value ends at BCD, and I have S2, and there's some values which ends at, let's say, ACD. I know that if both of these things match, right, D and D matches, then I won't delete it. If C and C matches, I won't delete it. But if I see A and B is not matching, in that case, I can either delete, let's say A. There is a possibility, right, that none of them matches. Will empty string match? In one step, you can delete exactly 1 character in either string. I think so. And both empty strings will match, right? What if these strings are like this? Like, what if the S1 is, let's say, ABC, and like S2 is Z. So in this case, I can never match this. So I have to make them empty. Makes sense. ACD. So in this case, I have the option. See, there could be a possibility that there's an A here, right? So I have the option here to, let's say, delete B. I delete B, and then in the next step, automatically this A and A will match. Okay, there's one option to delete B. In the next step, automatically A and A will match. Or there could be a possibility, but let's say there's no A in front of it, and there's some Z here. Doesn't matter. And there's some B here, right? So in this case, if I delete B, I can never match this A here because there's no A here, right? But if I delete A, then I'm sure that I'll be able to match this B with this B, and then probably this Z with, let's say there was a Z here. This Z makes sense. So in either one of them, I have the option to delete. Okay, so my result would be a solve function. I have to get the length of both of them. So in this case, that should be length of word 1. M is going to be the length of word 2, and up here itself I'll have indices for both of them. Index 1 is 0, or let's say I'll start from the very last index. Makes sense. So in this case, n minus 1, my bad, n minus 1, m minus 1, n is for word 1. So like I'll have word 1 here, word 2 here, and that's it. So at the end, I'll return result. So this is going to be defined solve. I have 2 indices, idx1, idx2, and let's say there's string s1 and string s2. So what could be the base case? See, base case could be very simple enough. Like, let's say my string s1 is something like this, abc, and like, let's say my string s2 is currently empty. What will happen right now? Now, if I know that, how do I know my string s2 is empty? Well, it will never be empty. Let's say it's ZZZ. I know, let's say my jth index comes up here, right? My jth index comes up here, right? It's at this point. My jth index or my idx2 comes up here, which means it's at 0 or it's less than 0, right? This is the second index, first index, 0th index, and this is minus 1th index. So I know if idx2 is less than 0, in that case, to match s1 with s2, I require how much characters to be deleted? 3 characters to be deleted. In this case, it's the length of s1. Or let's say my idx2 is here itself, right? My idx2 is at c itself. So it will be idx2 plus 1. Great, makes sense. So base case could be if idx1 is less than 0, in that case, return idx2 plus 1. Else I'm saying if let's say idx2 is less than 0, in that case, return, I guess, idx1 plus 1 makes sense. And what if s1 of idx, not id, but what if s1 of idx1 is equivalent to s2 of idx2? In that case, probably I can just simply return, like I don't need to delete anything, right? So in this case, I'll write something like this, no need to delete, right? So in this case, number of delete operations will be 0, plus I'll call the solve function, and I'll move both idx1 by one step backwards, idx2 by one step backwards, s1 and s2 will follow. Makes sense. But what if they are not equal? So I know that the two characters are not equal. In that case, what can I do? The two characters are not equal, right? So I have the option to delete the current character in S1 or current character in S2. So what's the way one? Way one is that I delete, so that's one for the delete operation. So when I delete it, I know I'll move it backwards. So idx1 minus 1, idx2 will be as it is. So I'm saying that delete in S1, idx2, and then probably S1 and S2 will follow. Way 2 would be, I'll say something like this, that delete in S2 makes sense. It's going to be 1 plus solve of idx1 will be as it is, idx2 will go down, S1 and S2 will be followed. And then I have to return the minimum of all of this. So return the minimum of both way 1 and way 2. That's it. Let's see. Runs like a charm. What about this Leetcode and this? So Leetcode and we have etco. This should give me 4, na? Two options to delete in S1 or delete in S2. Okay, great. Submit this. Should run. Time limit exceeded. Okay. Okay, can I optimize this, like delete operation for 2 strings? Acha, this could be like a DB thing, na? Ki like I use wanted to use hash map and then hash map. Then there could be time when idx1 and idx2 are at the same spot multiple times, right? So probably hash map will come up here. Hash map will come up here. Hash map will come up here and then here. There could be a time when both of them are at the same spot. So idx1 comma idx2 in hash map. In that case, I'm going to return hash map of idx1 and then idx2. And like in this case as well, this should be memoized. That should be hash map of idx1, idx2 is equivalent to this thing. And then return hash map of idx1, idx2. Great. Here as well, I'll just have this. Return hash map of x1, idx2. Let's run this. Running fine. Submit. time limit exceeded because I did not optimize it. Right now it should be a TP tag here, not dynamic programming string. Makes sense. Like delete in S1, the option is delete in S2. And if it's same, then I don't need to delete it. And every single time I'll optimize it. Optimize the state hash map of IDX2, IDX1, IDX1, IDX2. Okay. Let's see other problems. Longest string chain, minimum operation to reduce X to 0. Okay, I think so. Did I do this? I feel like I've done this. Minimum operations needed to reduce X to 0. I've done this, no? No, I haven't. Okay, let's see. You're given an array, integer array nums and an integer x. In one operation, you can either remove the leftmost or the rightmost element from the array nums and subtract its value from x. Note that this modifies the array for future operations. Makes sense. Return the minimum number of operations to reduce x to exactly 0 if it is possible, otherwise return -1. So like at any point of a time, I have the option to choose, or I have the option to remove the leftmost element of the array or the rightmost element of the array nums and subtract its value from x. Modify the array for future operations. Makes sense. So in this case, like x is 5 and there could be like अभी मेरे को दिख रहा है कि इसमें let's say the array is, let's say 2 2 2 and x is 5. So can I reduce x to 0? No. Even if I just reduce it all the way around, like all of them are even numbers and this is odd, so it never makes sense. Okay. So there could be a time when it's not doable. So in that case, I'll return -1 or I'll return the value needed. Okay. In this case, it's 5, right? So can I do it? What do we say? Greedily, like 3 remove keys, that's one operation. Then 2 remove key, that's one operation. So in two operation, it's done. 4, okay, it can never be achieved because 5 and 9 is there. Nums is 3, 2, 20, 1, 1, 3. X is 10. Okay. Hmm. X is 10. So if I go greedily, maybe I'll pick 3 from here. Remaining is 7. I'll pick 3 from here. Remaining is, I guess, 4. Remaining is, sorry, 3. If I pick 2 from here, remaining is, so 1 3 from here, 1 3 from here, 1 2 from here. So 3 5 8 and then, so probably 5 moves. Great. So like at the end of the day, I just have to find out that can I, like, what's the minimum number of moves from here till here? What's the minimum number of moves from here till here? And what's the minimum number of moves if I combine both of them, right? So it feels like I have to consider this array as cyclic. Start from some point. Maybe it could be something like that. See why this is not going to work greedily. The reason being this. I'll give one test case. Let's say the number x is, I don't know, 20, right? Let's say the number x is 20 and the array looks like this. Let's say 5 and then 5, right? And then let's say there's a bunch of numbers 1 1 1 1 1 and so on, and let's say we have 14 and then Okay, let's say we have something like 16 and then 4. Then what will happen in this case? See, if I go for a greedy approach, then I'll be like, okay, remove 5. So currently x becomes 15. Remove 5 again, x becomes 10 because I'm removing the largest number and not the smallest number. And remove 1, so this becomes 9. Uh, okay, not remove 1, but in this case I'll remove 4, so this becomes 6. And from 1 1 16, or from bunch of triple ones and 16, this is what my array looks like. If I remove 16, I'll be like, oh, this becomes minus 10, so this is not achievable. No, this is achievable, right? Because I'll just pick 16 and 4, and that's going to be 2 moves. So greedily it's not possible because the array is not sorted. There's no uniformity. There's no uniformity at all. Yes, at all. There's no uniformity at all. So I think so. Heap can be used or no? No, heap can never be used here, right? How can heap be used? Heap में minimum heap maximum heap कहाँ यहाँ पे use होगा? It can never be used. 3 to 20 1 1 3. Prefix sum, suffix sum concept can be used. Minimum operations to reduce x to 0. Okay. Let's say my result will be a solve. N is the length of nums. I need two indices, the first one and the last index, and yes, first one and the last index. And then here itself, I need nums and the value x itself. So at the end, I'll return whatever my result would be. Okay, so in this case, let's say define solve. I have the starting point, I have the ending point, like start index and index. From there itself, I can take the values nums and then followed by x. Makes sense. So my start and nums will go in this way. Start will go forward, end will go backwards. At any point of a time, if my start turns out to be equivalent to end, in that case, I'll see if x minus the value at that position is equivalent to 0. In that case, I'm like return 0, else I'm like return float infinity because it's not possible. Also here itself, I'll say if result is infinity, it means I can never achieve x as 0. So therefore, I'll probably say result is -1. Like this is just an, what do we say, edge case to handle this. Okay, that makes sense. Now, what if my x is 0 at any point of a time? In that case, I'm like return 0 itself. And if x is less than, no, I don't need to do that, right? Oh, I can do that. If x is less than 0, I'm like return float infinity because again, it's not possible at all. So what's the first way? First way is that if I subtract from the starting, so way one would be one move plus, like that's constituting one move plus solve function at cookie man, like I'm subtracting from this, right? Okay, I'm getting a call. Wait a second. Hello. Hello. Yes. सर अरे यार सर हाँ कैसे बताऊँ भाई अब मैं करके करता हूँ कॉल अभी जस्ट आई कॉल यू जस्ट अभी आई कॉल ओके 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 हाँ ओके ओके okay so start I'll go to start plus one, right? Okay, then what can we do? End is as it is, nums is as it is, x minus whatever the nums at start is. Makes sense. Way 2 would be that I subtract from the very end. That would be like start will be as it is, end minus 1, nums will be as it is, x minus nums of end. Makes sense. Now in this case, like at the end of the day, I have to return like the minimum answer. In this case, I'll say minimum way. That's bad. Minimum way is min of way 1 and way 2, and then I'll probably return minimum way. Makes sense. Let's run this. This should run fine if I'm not wrong, but yeah, runs fine. Let's have this test case. In this case, it's 5 6 7 8 9 5 6 7 8 9. So let's have this here, and 4 is going to be here. Run code. Minus 1 should be the answer. Sweet. Here it should be, I guess, if it's like, yeah, this is, let's say 10. The answer should be 5. My output is minus 1. 3 2 20 1 1 3, and x is 10, and output is minus 1. Expected is 5. Makes sense. Okay, so if x is 0, I return 0. If x minus nums of start is equivalent to 0, I return 0, because I can form that, like I can reduce x to 0, right? Or the best part I can have is, instead of this, if start is greater than end, or let's say start is greater than equivalent to n, or end is less than, what do we say? End is less than 0. In that case, return float of infinity, because that's not something I want. And in this case, like I'll probably have both of this here. So let's have this. No. This here itself, and let's paste this. Name n is not defined. Do you mean ne? Where is n? Okay, n is not defined. I'll pass n here, no problem. So like n will be passed here, n will be passed here, and then probably like n will be passed here. No, it's not here. My bad. So it's going to be here itself. If I run this, if it's not working, I have to look at the discussion. It's working fine, right? I think so. I messed up that part. Okay, so let's submit this. If it's TLE, then it's DP solution, dynamic programming. If it's not TLE, then I'm wrong. TLE, great, TLE. So I can just optimize this. Hash map comes up here. Excuse me. Hash map comes up here. Then probably hash map comes up here. Hash map comes up here. At every like I think so at every step I just need to do something like this, that if let's say my start and end in hash map, in that case return hash map of start and end, because if I do x here, that then will never make sense, because never make sense at all. Hash map of let's say start and end is going to be minimum way, and then I'll return whatever my minimum way is. Let's run this code. By the way, let's run this entire thing. Copy this, paste it here. If it's running, then I know ki it's not TLE anymore. Please run. It's running fine. Let's submit this. Again, dynamic programming. Please run. Its time limit exceeded for another test case. This is what the test case looks like. I think so. I should never have X because X is going to make it a lot more complicated. Okay, my bad. So like this should probably come up here now. And if I take this entire thing, if I run this, it should work. But if I take this another thing, then let's see if it's working or not. Paste it, run the code. After to run this, run code. Is not a valid value of type integer. What is it saying? Okay, this is the entire thing, right? Let's copy this. Invalid test case. Why? Okay, so right now it makes sense. Huh. Huh. As in general, it's working fine now. Then what's the problem? अच्छा, I guess वो बार बार start and multiple times आ रहा था, so that might be an issue. How is Python slow today? Like usually it's all done, right? If I if I like individually, okay, let's copy this thing. No, not this, but like this entire test case. If I copy it and paste it here, it's running fine. Correct? Yes. Yeah, this is going to run fine here, I guess. Judging, and I think so. It's giving me TLE accumulation of all of the test cases, right? It's going to run a lot of test cases. If start is greater than end, or start is greater than equivalent to n, or end is less than 0, return float infinity. If x is less than 0, return float infinity. स्टार्ट एंड एंड को मैं ऑप्टिमाइज कर रहा हूँ इसमें हैश मैप में. So at the end of the day, what's happening? It's big of n squared solution. 10 to the power 5 square is it's never going to run. What could be done here? Let's look at some hint related topics. Sliding window, prefix sum, binary search. Okay, sliding window, prefix sum, hash table. Okay, similar questions. क्या क्या है? Okay, hint one क्या है? Think in reverse. Instead of finding the minimum prefix plus suffix, find the maximum subarray. maximum subarray such that its sum is equal to x. Okay, finding the maximum subarray standard can be done greedily. Okay. So in this case, like, maximum subarray makes sure that okay, so in this case 1 1 4 2 3, if I find the maximum subarray, then how can it be done? uh, X subarray sum which is equivalent to 5. Think in reverse. Instead of finding the minimum prefix plus suffix, find the maximum subarray. Finding the maximum subarray is standard and can be done greedily. So what's the prefix here, by the way? The prefix is this thing, right? I mean 1 2 6 8 and 11. And what is the suffix? It's going to be I guess it's going to be 3, then 5, then 9, 3 5 9, then 10, then followed by 11, right? This is what my suffix would be. Acha, so idhar mein binary search can be applied. Let's say I have 1 here, then I'll look for a number 4. Is it here? No. Great. I'm at 2. I look for a number 3. I'll binary search 3 here. Is it there? It's there. Okay, makes sense. Now I'll do the same thing from here. With respect to 3, I'll find 2. It's there, yes. 5, I don't need anything. Like 0 is something I don't need. So okay, makes sense. Like in this case, like the test case is like 3. For this one, the prefix will be 3 5, I guess 25, 26, 27, then 30, and then here it will be probably like 3 followed by 4 followed by 5 followed by 25 followed by 27 followed by 30. So here I can also do binary search now. I was making the problem complex. So if I do a binary search here, so 3 remaining is 7. Can I do a 7 here? No. 5 remaining is 5. So can I do a binary search 5 here? Yes. So required is 2 plus 3 5. Answer is 5. That's it. Okay, that's it. So instead of doing this, I'll do this. Hint is very important. Like n is the length of nums. I'll create a prefix array which is very simple, 0 into length of this thing. I'll create a suffix which is again very simple, which is 0 into n for I in range of अच्छा इधर मैं बोल देता हूँ कि like my prefix of 0 is probably nums of 0 and my suffix of n minus 1 is going to be nums of like -1. I can even just use -1 here. Python में negative indexing is supported. And then I'll say my prefix of I would be probably nums of I plus prefix of I minus 1, and then for I in range probably n minus 2 till -1 till -1. Suffix of I would be suffix of I plus 1 plus nums of I. Yes, makes sense. Let's print like prefix and suffix to make sure I'm going right way. Let's have this test case. X is 4. 5 11 18 35 35. Yeah, makes sense. It's 35, right? Yeah. So suffix prefix to ban gaya. Now what will I do? I'll binary search, right? So I'll go two-way. Like firstly, I'll loop in prefix. So I'll say loop in prefix and binary search in suffix, or I'll have the option to loop in suffix and binary search in let's say prefix, right? So in this case, what can I say? My minimum answer or minimum moves required is minimum moves or minimum elements required is initially 0 because I cannot form the array here, right? Can the x be 0? No, it can never be 0. So minimum moves 0 makes sense. I'll initialize this up. Minimum moves is initially 0. So here itself I'll say let's loop in the prefix. So for I in range n, current value is prefix of I, and taken, I mean taken is basically number of elements which are taken. Taken is I plus 1. So target, my target value is nothing but x minus current value. So in this case I'll say that if my target, also एक यहाँ पे edge case है कि if my current value is equivalent to x, in that case I have the option that I'll say my minimum moves is minimum of whatever my minimum moves is, comma I plus 1, and then I'll probably break because this is the, what do we say, breakpoint, right? Because if it's x, I don't need to go further. Now if target is less than 0, I know ki, if target is less than 0, I know that I have to break. Straightforward. Else I'll search for this target in suffix. So start is 0, end is n minus 1, and suffix is how is it sorted? It's sorted in descending order, right? So I'll say while start is less than equivalent to end. In this case, my mid would be start plus probably like end minus start by 2. I'll say that in my suffix array, if the element at mid is probably greater than target, in that case, Acha, let's say if the element at this position is equivalent to target, in that case I know that I'll have the value as, let's say found is equivalent to -1. So I'll say something like, let's say found is equivalent to mid, and then I'm breaking elif, or let's say if the element which is suffix of mid is greater than target. In this case the suffix looks like this, let's say 10 5 3 1, and let's say I'm at 10 and the value to search is 3. So 10 is greater than 3, so I'll go to the right. So start is mid plus 1, else I'll go to the left, end is mid minus 1. Makes sense. And I'll say here itself if found, which means okay, the value is if found is equivalent to, or found is not equivalent to -1, in that case I know that I found the element. Therefore let's update this. So minimum moves is minimum of min moves, comma taken वेकन का यहाँ पे ज़रूरत नहीं है, right? So cringe, taken की ज़रूरत नहीं है. So let's have I don't know, like I plus 1, which is because of the very first कि मैंने I plus 1 elements consider कर लिया. इधर mid है, right? So what's mid? Let's say elements are 5 and mid is at 0 1 2 3. So is it 4 elements? No, it's like 0 1 2 3, 5 minus 3 minus 1. Okay, so this should be like n minus whatever my found is, 5 minus 3 minus 1. These many elements, right? 5 minus 3 is 2. Okay, so this should be like 0 1 2 3, 5 minus 3 is 2. Makes sense. Okay, this is how it will be updated, else it won't be updated at all. And I have to do the reverse thing here, that let's say like the entire thing will be reversed. Let's copy this and probably I'll paste this here. Current value would be, let's say, suffix of I, and I'll go from n minus 1 to -1 to -1. Current value is suffix of I. If current value is equivalent to x, minimum moves is this thing, or it can be also said it's n minus I. If it's 3, then makes sense. And break, target is x minus current value. If target is less than 0, break. Hmm. Because I can never find a negative element. Start is 0, end is n minus 1, found is minus 1. इधर में क्या है कि if prefix of mid, yes, if prefix of mid is equal to target, then found is mid. And if prefix of mid is greater than target, then my end will be mid minus 1, right? Because prefix is sorted in ascending order, so mid minus 1 makes sense. Else here it would be simply, let's say, start is mid plus 1, makes sense. And if found is equivalent to minus 1, in that case, this should be probably like n minus I, and this should be like mid plus 1, or found plus 1. Yes, found plus 1. At the end, I can probably return min moves, if I'm not wrong. Okay, let's run this. Output is 0, expected minus 1. Okay, so I'll say if min moves is equivalent to 0, in that case, return minus 1. Else I'm like return min moves itself. Should work fine for all of them. अच्छा, minimum moves का problem है, right? Hmm. 11423 वाला टेस्ट केस तो चलना चाहिए ना, फिर प्रॉब्लम क्या हो रहा है? 1 1 and then 3, so expected is minus 1, output is 3. Okay, let's see. 1 and 1 is there now. Acha, this I should never cross this mid, right? So in this case, again, like if found is not equivalent to minus 1, and I is probably, let's say, less than found, right? Should not be less than equal to found. So here as well, found is not equal to minus 1, and probably my I is, or we can say like found is less than I, right? Now this 113 should work. This test case I never handled. 1 and 1, and then like this 3 should work right now. This should give me minus 1. Give me minus 1, please. Please. Minus 1, submit. A good edge case. I failed to handle this. Makes sense. This will not work because I don't know क्या हो गया था problem. TLE, right? Time limit exceeded. Makes sense. Because like it's a big O of n square solution, and n square हो गया कितना? 10 to the power 5. 10 to the power 5 square is 10 to the power 5 5 0 10 to the power 10 हो गया, right? गलत हुआ. हाँ, I guess 10 to the power, हाँ 10 to the power 10 हो गया, right? हाँ. Which is like more than a million. And this solution is like the first loop is running for at max n times. This is going to be n log n, like n log n upar wala, and then this is n log n. So 2n log n, which is close to n log n itself. It's a good question. So just by reading the hint, like binary search and prefix sum, makes sense. The company tag. Okay, I'll resume the stream. After some time, I'll resume the stream. I'll close it right now.